Hello and welcome to our presentation for MBC 638. So I am Rohan and my team members are William, Pranjali, Shanshan and Minyang. So we are also known as the Group 21 consulting firm, and we are going to be predicting the restaurant rating of restaurants from Zomato. So the reason why we chose this data set is because currently the competition in restaurants has been increasing day by day, and we wanted to provide an analysis on an existing data set to help restaurant managers and clients discover what factors can best predict their restaurant rating, what could help their restaurant to be better than other restaurants. So that was what our team's project was, and we are acting as consultants to suggest clients ways to improve their restaurants. So we mainly use factors such as average cost, price range, the votes given by other customers, and services provided by the restaurant. So basically, that's what the foundation of our project is. And so at first, to describe our dataset, we used a dataset from kaggle.com. I have given the link in case it wants to be looked into. And we also chose to use this dataset because Zomato, out of all the other restaurant apps, because Zomato is the most well known and most used restaurant app to see restaurant reviews and restaurant ratings. Like me and my team members, all of us use Zomato. So basically, that's why we decided that this would be a really interesting topic to cover up on, and something which not only restaurant managers but even from a customer's point of view, like ourselves, could also see what kind of factors deal with it. And since we are also comfortable, since most of us use Zomato, we all are pretty much comfortable with what kind of data we are working with. So our data set has 9,552 rows and 21 variable columns of data. So the variables which are included in this data set are restaurant details such as restaurant ID, restaurant name, the country code, and what city the restaurant is in, the address, the locality, even the coordinates are given, and the restaurant, what cuisine they serve, what, and then main are the prediction factors which we eventually used, which were the average cost of two, the currency, the table with the restaurant services, like whether it has a table booking or an online delivery, and whether it's delivering themselves. So we've used a few dummy variables as well in that. There are also other factors such as price range, and then finally the ratings and what votes it had. So basically, going to our descriptive statistics. So first we decided to take the aggregate rating, as that is what we're going to predict. That's why that is going to be a dependent variable for our predictive analysis. To describe it, our data is left skewed. It can be seen that the average aggregate rating is about 2.5 to 2.6, and the median is 3.2. So that is where the average rating falls under of restaurants, which is pretty average compared to how restaurants are usually reviewed on Zomato. So basically, the average cost of two basically shows what is the average cost when two people usually go to a restaurant. So basically, it can be seen that the average cost is pretty varied. We've done a count over here to show how our data set varies when it comes to the average cost. Also, the average cost isn't in any specific currency. It corresponds. We looked into the data set. This is one of the problems which we faced. We looked into the data set and we saw that the average cost of two has been centralized to a particular number depending on the currency of the restaurant which is used. So that is how it has been integrated into one data set, and that is how it is going to be a factor which is going to be used for predictive analysis. So basically, for descriptive statistics, we've used the price range, and we've seen that the price range basically varies a lot. So about like 46% of our data set has a low price range, and about 6% has a high price range, which is a range of 4. So basically it can be seen in this data set is that there are more restaurants with lower price range, and there are less restaurants with higher price range, and the percentage of these restaurants, there are lesser and lesser restaurants as the price range increases. So basically, as we can see that these are the descriptive statistics for the votes variable. So basically, the histogram is pretty interesting to see because we can see about 6,000 values only on the start, and whereas the histogram goes all the way up to 1,000, sorry, like up to 10,000 votes. So basically, this histogram is what it's trying to tell us is that there are votes ranging from 0 to 71 to 10,000 votes, and there are about 1 or 2 restaurants which have votes in that category, which is why the histogram is so huge and we cannot see any points over there. Whereas there are about maximum votes in the 0 to 71 range, and then there are restaurants which about 1,000 restaurants which are voted from which have about 100 votes, and so on. There are lesser and lesser restaurants which have about 200 or 400 votes, but there are a few restaurants in our data set which are about 10,000, which have 10,000 votes, which is why the histogram's range is so high. So basically, we also describe the variables which are categorical variables. The variables which I described till now were quantitative variables. So these are the qualitative variables which we're going to be using. These are the hotel services, the restaurant services, whether it delivers, it does online delivery, or whether it has table booking, and whether it's delivering now. So basically we have done bar charts for that. So it can be seen that there are more restaurants which uh, deliver and have table booking and have online delivery have comparatively higher ratings, and this is explainable as having these services are some factors which are helpful to predict what kind of rating a restaurant could get. We'll be talking about more about these services and which one affects how much does one service affect the aggregate rating in the predictive analysis. So we wanted to do a quick overview of where the restaurants we've used in this data set and this analysis are located. So it can be seen that the restaurants are located pretty much all around the world, but there are more number of restaurants in the United States and in India. So we made a heat map, which is one of the reasons why we did not remove the longitude and the latitude coordinates from the data set. Also, before we start explaining the predictive analysis, just wanted to add in that one of our team members wanted to explain this part and do the presentation to this part, but due to some technical difficulties on his laptop, he wasn't able to. So we'll be proceeding with the regression analysis. So before we get into the regression analysis, we just want to show the individual correlation of the aggregate rating with the other variables. So as shown on the table, it can be seen that the aggregate rating is individually correlated to all of the other variables which you're going to use. So we're going to get more into that in the upcoming slides and explaining why this happens, but we just wanted to show an overview of the individual single regression analysis and how and which variables were correlated and how they are correlated. So we also did another single regression analysis where there's a relation between the aggregate rating and the price range. So it can be seen in the scatter plot that even restaurants with lower price range have a equal amount of aggregate ratings which are high and comparatively low as well. But there's also an upward trend line, and it can be seen that there is a positive relationship between the price range and the rating as well. So this is similar to the previous regression we did, where wherever the cost is more, the ratings of those restaurants are specifically more. even the r squared value over here is 0.19, and that means that the regression is explained by almost 2%, or sorry, 20%. And even in the previous regression, the uh, the explanation between the votes and the aggregate rating is also higher compared to the previous regression which we had done, the first regression. So we also did a regression between the dummy variables. So we use the restaurant services as our dummy variables, and as it can be seen that the table booking has a comparatively lower R squared value, which is why the regression is not that well explained. But this makes sense because having a table booking doesn't exactly define a restaurant's rating. That is not a factor which a reviewer or any customer would basically consider to give a low or a high aggregate rating. The same, so for the next dummy variable which we used whether the restaurant has online deliveries. This is currently a really big topic to discuss, as online deliveries is now being a thing. So basically, the R squared value and the regression is explained better in this, which is about 5%. But it is still comparatively low compared to the previous R squared values which we had. This also means that the restaurants which have online deliveries are more convenient for customers, which is why they pretty much rate restaurants higher than the ones which don't. So we did another regression on the dummy variables. So then we even used whether the restaurant itself delivers or not. So that's why we performed a regression on that. And it can be seen that even this doesn't really pretty much explain the regression that well. But it does have a positive correlation, and that means that restaurants usually which deliver will eventually get a high rating. But this still doesn't really explain the regression that well. So the predictions of these three dummy variables, out of them, the one which does the online delivery predicts the best out of all the three. And usually especially for this one, the delivering restaurant, it doesn't really matter because nowadays a lot of separate apps and services are there to deliver food from other restaurants. So whether the restaurant even has anything to be delivered themselves doesn't really make a difference nowadays. So then we even used regression analysis on interaction variables. We interacted the dummy variables with the amount of votes, because the votes mainly describe how good the rating is of a restaurant. So we first did it with table bookings, and as it can be seen, the adjusted R square is about 0.12, and it explains the regression by 12%. So this is higher than the dummy variables, and this makes sense because when we add more values to the regression, it pretty much does a better explanation. The same goes for online delivery. The regression is explained by 9%, which is much more compared to what it was before. And for the restaurants which deliver it, the regression is explained by 15%. So basically, what we learn from interaction variables and why we use them is that we can correlate mainly what certain predictors align with certain other predictors. Like for example, in this case, we used whether the restaurant services are related to the votes, because more restaurant services will usually include more people to give higher ratings and more votes. So basically, this is why we use interaction variables, and this is how we've done our interaction regression. It also proves that this is better than just considering dummy variables. So one of my other teammates now will be explaining the stepwise regression, which is also going to be including more variables. But before we get into that, I just to explain the multiple regression model. So this is the main part of our regression of our predictive analysis which we've done. So basically, the regression shows that um, from this model, what we learned that the price range, the votes, and the services of online delivery and the table booking are statistically significant, as their p-values are lesser than 0.0001 compared to the others. Also, what we learn is that these are the best predictors we should use for predicting a restaurant's aggregate rating. So now I will be uh, this thing. So I will be concluding the regression analysis here, and one of my teammates will be explaining the stepwise regression and the actionable insights.
So, uh, to identify that our analysis is more accurate, we decided to perform stepwise regression. We initially started by predicting the aggregate rating based on price range. So as you can see, the p-value is really good here, but the adjusted R-square is pretty low. So in order to see how accurate our model is, we added more variables. So another one of them was votes. This increased our adjusted R-square value, not that significantly, but a bit significantly. So as we went step by step, we found that the average cost for 2 is not at all valuable because the p-value is high, and the online variable and the table booking have a big significant other than price range and votes. As you can see that the table booking has a negative impact when we add it. However, the adjusted R-square is increased to 0.2626. So this is our final regression equation, and based on it, we suggest that the price range, votes, online booking, and table booking are big predictors to identify the aggregate rating. However, the lower and upper confidence interval is not that high. So based on this, we have some actionable insights that we want to suggest to Zomato and its users. I will just go briefly through it. So the first insight is that the restaurant should add online booking service, because based on this they can get more customer reviews, and based on the reviews they'll have a higher chance of getting a rating. The second is adding a delivery option. So as we can see that through multiple regression, we were able to identify that delivery has a big impact on the number of votes as well as the aggregate rating. So it will impact the customer service of the restaurant. The third is focusing on adding online deliverables and table booking. So since table booking had a negative impact, maybe the restaurants should work on getting more friendly service to the customers, and like when they are coming to the restaurant, it should be more valuable that they serve the customers diligently in order to get higher ratings and get good feedback in the end. Other than that, based on different price range, there were different ratings. So it seems that the customers are more tend to rate the higher price range restaurants more often. That means the lower price range restaurants should also focus on improving their service within their budget, of course.
So to add to that, who will be using this predictive analysis? So basically, there are four targeted people or factors who are going to be using our analysis. The first being restaurant managers. Restaurants can focus and use this kind of analysis to see what makes their restaurant better rated. Then there are delivery services like Grubhub or Topingo. They could also use this service to collaborate with other restaurants, and since they will be knowing that online delivery plays a major role in prediction. So even the third factor who can use our analysis are websites like Zomato itself. They can improve the UI. They can add what the depending on which factors describe the aggregate rating. They could either increase their text size or their box size for votes, or whether a restaurant has online delivery or not, because those are the main factors by customers use to rate restaurants. So they will be looking for those factors at first. And also mainly reviewers, restaurant reviewers, the ones who actually review restaurants, they could focus on these points and they can mention them as these are the main factors which predict a restaurant's rating. So that concludes our presentation. I hope it was good, and I will be concluding the presentation right now.